Okay. So next topic we can see what is the comparison of conventional and smart grid. Okay, conventional grid or traditional grid. Okay, and smart grid. We are going to compare it. So before comparing it, we can see what are the benefits in traditional grid and what are the benefits in smart grid. Okay. So see here, in traditional grid, so what is the way? It is a centralized system. Okay, that is here the power flow is from single direction only. So that is from generating station, we are transmitting and distributing, and finally to the grid. Okay, so this is only one direction. The power flows is from one direction. That is from generating sources to transmission, distribution, and to the customer. So this is the one directional power flow. Next, it is a centralized system. Okay, what is centralized system? Centralized system means throughout the substation. For example, we can say that the main central it will be located in one particular position only. Okay, if it is decentralized means it can be located in the same area itself. So for the same area, it has some branch, but centralized system, it has only commonly located in only one station alone. Okay, that is one central station alone it is available. So that is a centralized system. So whole thing is located in some distance. Okay, so what happens? So if it is some located in far more distance means the losses will be more because we have to transmit it to that particular position. Okay, isn't it? So that there will be more transmission losses also possible. Okay, so here it is the system is centralized one, and the thing is the power flow is from one direction only. Okay, so see here centralized generation means it is located in same geographical area as the load being served. Okay, which it often requires the transmission from some distant location. So, okay, it is located at some distance. So it requires often to transmit from that position to another area. Okay. So next is it has a lack of controlling system. That is lack of SCADA sensors and some communications related to monitoring. So some of the monitoring sensors are now lacking. Okay. Next is it requires some manual operation. That is periodically we have to operate it manually. So it requires some manual operation. So these are the thing in traditional grid. Okay, it requires some manual reporting system and manual operating. Okay. Next, the billing system. That is for billing, for ensuring the bill also, it requires one particular period only. So one particular period it monitors some billing system. But in a smart grid, it can be evaluated by consumer itself. So consumer itself can able to aware of that periodic billing, aware of that bill system. Okay, so here it is lagging. Okay, so these are the thing in traditional grid. We find some difficulties in traditional grid. Okay, next in smart grid, see here if you compare it, the smart grid has a power flow in both directions. Okay, so this is one advantage compared to traditional grid. It has the advantage of two-way communications. That is two-way power flow system. Okay, that is here the direction of power flow from generating resources and transmission distribution system to consumers and vice versa. We can able to generate it back also. Okay, so that is two-way power generation. So similarly, it is a decentralized one. Okay, so opposite to centralized one, it is a decentralized one. Okay, so here it is as it is a decentralized one, it can be located near to the system. Okay, so here the transmission losses also will be reduced. Okay, so as it is a decentralized one, transmission loss also can be decreased. Okay, so here it is in the same geographical area itself will be located. So next is here it has a reduced risk of failure, because we know that here it has advanced features and it has more sensors and more features are available. So, okay, so monitoring also it can able to it has a self healing, and it is resilient. So as it has more features, so it has a reduced risk of outage. That means it has a reduced risk of any failures. Okay, so here more SCADAs, sensors, and capacitor banks, reclosures, relays, like that. Here more protective materials are enclosed, so it is free from any outage, any failures. Okay, so then it has a smart appliances system. That is, customers can able to operate it more user friendly. Okay, he can able to aware of energy consumption. Okay, so these are a thing we identified in smart grid technology. So we are identified some drawbacks in traditional one, and we identify some advantages in smart grid. So we are going to compare it as we studied before. Now you can easily compare it traditional grid and smart grid. Okay, so see, now we are differentiating. So traditional, this is very important. Okay, this is very important topic. So how we are comparing the traditional grid to the smart grid. Okay, so first thing, what is the thing we identified in traditional grid? We identify that it is a one-way communication. Next, smart grid is a two-way communication. Okay, so I already know, because it is a from one from generate, it is power from one way only. Next is one way energy transfer. So here in smart grid it is a two-way energy transfer. Okay, so next, what is the thing we identified in traditional grid? We identified it is a centralized generation. Okay, so it is a centralized generation, but in smart grid it is a distributed generation. So otherwise we can tell it as decentralized generation. Okay, so this is a hierarchical structure. Next is it is a network structure. So hierarchical and network you already know. Network, it depends upon two or more connections at the same time, but hierarchical, it is a structural flow. It will be from one way only. It will be depends upon one way only. Okay, that the flow will be very unique. So next, few sensors are used. So in traditional system only few sensors are used. So in smart grid full systems is employed through some sensors only. Okay, so this is sensors are throughout. We are using majority, we are using the sensors. Next, see blind. Traditional system is blind. So why here indicating blind? And here self monitoring. That is, it is lack of monitoring. The monitoring is very poor only. Okay, that means compared to smart grid. So here it is all the thing is manually we have to correct it. So it can't able to correct it automatically. Okay, so we indicate this, it is known as blind. And smart grid, it is a self monitoring. I already told the control is fully monitoring, and it can able to self heal also. So this is self monitoring. Next, traditional grid, it is a manual restoration. That is, manual means it requires some human intervention. Okay, some human beings are required to identify the fault and restore it. But in smart grid it can able to identify the fault, and it can able to self healing itself. Okay, so this is manual restoration, and smart grid is self healing. Next, in traditional grid there are many possibilities for failures and blackouts. Okay, because this one is some tedious process, and it requires some time to restore it. Okay, so that it will it can face a problem for failures and blackouts. But in smart grid it is adaptive and islanding. That means if any fault is detected, then we can able to prevent it from disrupting the whole system. Okay, so it can prevent it from that whole system affecting. So it will prevent from the whole system affecting to, and it can able to save it. That means it can able to replace the particular thing. Okay, that is separating. We can identify the fault, and you can able to isolate it, the separate fault alone. Okay, so next is here manual check. We are so here it requires human beings, and it requires some operators to check and evaluate it. But here we can able to check it through remote system. That means we can look if we can
from distance areas of we can able to identify it, can able to monitor it from remote area. Okay, so remote check or test is taken out in smart grid. Here traditional limited control, only limited controls is possible. In smart grid, huge control is possible, wide control is possible. Next, in traditional grid, only few customers are preferring this choice for traditional grid. But many consumers are ensuring, many consumers or choice will be smart grid only. Okay, because many features are available here, so many customers choice also depends on smart grid only. So next here, traditional, this is larger in size, and here the smart grid is small, compact. It is small, it is compact to use. Traditional grid is a low efficiency because losses will be more. So if losses will be more, efficiency will be poor only. Okay, but comparing to smart grid, so it has a relatively high efficiency. Okay, here losses are reduced, so here the loss efficiency is more. So next thing, it has losses. Okay, that means transmission and distribution losses are more. That's why we have the low efficiency in traditional grid, isn't it? So next point is transmission and distribution is losses are high here. So here in transmission distribution losses is very less. Okay, so these are the thing we identified. That means comparing to traditional grid, we are identify some of the advantage and disadvantage, so that we are comparing it with traditional grid. Okay, so these are the thing. So next topic we can see in next class. Okay, so thank you students. If you have any doubt, you can ask me. Remaining topic we can discuss in next class. Thank you.